Hey guys, gonna go through some year 10 leading into year 11 trig problems that I've drawn up. So hopefully it goes forward without a hitch. So for this video, I'm just gonna go through each question. So you should pause on each one, give it a crack yourself, and then you can watch me go through it. So the first one we're gonna do is this one here. So it's a right angle triangle, so that's good. We can deal with this pretty easily. First thing we want to do is label our sides. So that's opposite that angle, and this is the long side, so that is the hypotenuse. Remember that right angle points to the longest side. So when I look at my mnemonic, so, ka, toa, I need to determine which one of these I'm going to be using, and it's O and H, so I'm going to be using the sine rule. So if I took sine of 28, if I just decimalize that angle with sine, well, that's the same thing as if I took x, took the opposite and divided it by the hypotenuse. Now we want our unknown to be by itself, so what do I need to do to both sides? I need times by 10. So 10 sine 28 is equal to x. And I just jump on my calculator and I can plug that in. So 10 sine 28. Cool. So x equals 4 we need to go, we'll go 4.69, and our units are meters. So that is our answer. So notice on the calculator I haven't done the times and I haven't closed the bracket. It's because this is more of a modern calculator, so it kind of gets the understanding of what I'm doing. But if you're gonna try and put this in an older calculator, you probably have to do it perfectly. So it'll be 10 times sine 28, and you'd close that bracket. That's more of the perfect way of doing that. Cool. So next problem. So if a plane took off at an angle of 25 degrees, when it's 3 kilometers high, how far has it traveled horizontally? Yes, that is my poor attempt at drawing a plane. So give that one a crack. All right, the first step you want to do is label the sides. So this is the opposite and this is the adjacent. So in my mnemonic, I'm dealing with tan. So if I took tan or tangent of 25, that would be the same as taking the opposite and dividing it by the adjacent. Now notice our unknown is on the bottom, and we have a move for that, as covered in a previous video. We call that the switch. Right, we can just switch those around. So x becomes tan 25 and tan 25 becomes x. So we can go x equals 3 over tan 25, and there's no particular reason why I switch between the capital and lowercase, but it's something I seem to do. Might be because I'm thinking that's a start of a sentence or something. So if we were to put this in a calculator, it'd be 3 divided by tan 25. What do we got? 6.43. So x equals 6.43, and the units there are kilometers. Okay, so if the plane took off at 25 degrees, when it's 3 kilometers when it's 3 kilometers high in the sky, it would have traveled 6.43 kilometers across. Question number 3. This is a pretty tricky one. This is leading more into year 11. I want to know the width of this triangle. Okay, so what we do know is that this is an isosceles triangle. It's got the same angle in both the corners. So the trick to this is that we split it down the middle. We make it a right-angled triangle. Now we know that that's 3.2. So what I tend to do is I tend to redo my triangle with just the bare minimum information. So 65, 3.2, and it's this side here I want. I'm going to have to double it because I want that total width. So I label my side O and A, and again it's going to be a tangent, it's toa. So if I took tan of 65, that would be the same as 3.2 over x, the opposite over the adjacent. I can do the switch because my unknown's on the bottom. And so I just chuck that in my calculator and I'll have half of the width, won't I? 3.2 divided by tan 65. What do I get? 1.49. And the width will be double that. So 2 times the answer, 2.98. And that's in meters, because that height has been given in meters. Okay, that's the first 3 problems done. I've got 3 more for us. So let's have a look at this one. All right, so this one is it's a rugby field. All right, so a few of you boys who play rugby will be, or even if you played football. Okay. Say a try was scored 10 metres out from the post, so that length is 10 metres. The kicker wants an angle of 38 degrees, right? Or it's 38 degrees to the post. We want to know how far back the kicker will be standing, okay? So, or maybe it's football and that's the goal, okay? 38 degrees, 10 metres away from the post. How far back is that kick going to be made? So first thing we do, label our sides. O and A, again, tangent. Haven't really thought these last 3 problems through enough. We've had tan every time, I think. So if we took tan of 38, that's equal to O over A, 10 over X, and yep, we do the switch. So X is equal to 10 over tan 38. So 10 divided by tan 38 gives us 12.8 meters. 12.8 meters away. Okay? So it's almost which makes sense, right? Because it's almost 45 degrees. It's only 7 degrees off being 45. And a 45-degree right angle triangle would have the same length for the opposite and adjacent there. All right, we're up to question 5. So let's have a look at this one. All right, we're trying to find this angle. So finding angles is what most people usually get a little stuck on. It's because it's quite a unique process. So first of all, we still label. That's O and H, and we don't know this angle here. So it's going to be sine, so sine of the angle B or beta, or whatever you want to call it in there. It's a B. Sine B is equal to the opposite divided by the hypotenuse, O over H, 1.2 over 10. Now, we want to just have B by itself, so our little trick is that we go sine inverse. In previous videos, I've explained how most functions at high school have an inverse. So if we go sine inverse 1.2 over 10, we will get our angle. So we go shift sine, gives us our sine inverse, 1.2 divided by 10, and this time I really do need to close that bracket because it's sine inverse of 1.2 divided by 10, and we get 6.9. 6.9, and what is the unit? What's an angle? So it's in degrees. So if this was some sort of skateboard ramp, okay, it's 10 meters long and 1.2 meters high, it would make sense it'd have a very low incline, wouldn't it? Or angle, because that is actually going to be quite a small drop compared to its length, so it's going to be very small. Okay, last problem. What I'm going to call this one is one of those new modern roofed houses. So it's not your typical A-frame. It's got more of a monoplane roof. So we have one of the walls on one side of the building is 8 meters, and one of the walls on the other side of the building is 5 meters, and the length of that roof is 12, and we want to know that angle. So you might want to just give that a go. Now what the trick here is that we can create a right angle triangle by just going straight across there at a right angle. So now our triangle has got this relationship, a triangle on top. We want to know this angle. We have this length here, which is 12, and that right angle is pointing to that. So that's the hypotenuse. What other information do we have? Well, if this is 8 and that's 5, we've gone straight across here, that leaves us with 3 for that length. So that's 3. Now we've got a right angle trig problem, and we can get labeling and solving. So that's A and that's H. So A for adjacent and H for hypotenuse, because that adjacent angle is it's next to that angle there. Sorry, the adjacent side is next to that angle. So we're using cosine. So if I was to take cosine of A, that would be A over H, or 3 over 12. Now you could go and simplify this fraction to 1/4, but it's not necessary in trig. What we want to do is just have the angle A, and you get that by taking the cosine inverse of both sides. Remember that you'll need to go into brackets. So shift cos, and that gives us a cosine. See that little cosine, that inverse, or to -1, and that is 3 divided by 12. What do we get? 75.5 degrees. 75.5 degrees. If any of your parents are engineers or builders, maybe ask them if that is a legitimate angle to have in that roof, because there is some specific regulations about those mono-angled roofs. So there you have it. We've done a couple of problems finding angles, and we've found a few side lengths when it's been given as a numerator and a denominator. We've done them both. So here we have it. That is today's lesson. Any questions? Hit me up.